I'm going to begin with World Book Encyclopedia from 1963. And this is one of the encyclopedia sets that I grew up with. Everyone had the World Book Encyclopedia when I was growing up. All of the school libraries had them. This was a mainstay, absolute mainstay. And on page 6 here, we're going to look at it. Development of the Ice Age. This is all pretty general, but let's get a little background. About 1 million years ago, the Earth grew very cold. This was not a sudden change. The world had been cooling down since the close of the age of the dinosaurs, about 60 million years ago. But this last cooling was marked by a series of 4 climaxes, one after another. 4 great ice caps formed over the northern part of the world. At the same time, a series of 4 great glacier systems covered the high mountains, even at the equator. Okay, now right here, it gives you 10 different glacial periods. And here's the age, when they began. And the last one, 10 to 25,000 years ago. Now these, they all have real accurate numbers, how many millions of years ago. I just find it funny that the last one, they can't figure that one out. The recent one, 10 to 25,000 years. But how come these later glaciers didn't just wipe out all evidence of the first ones? I'm just asking. Let's look at a map associated with the glaciation theory here in World Book Encyclopedia. And we're going to notice here, Greenland, well, all the arrows just go outward here. So that means that the main compaction actually had to come from the center of Greenland, did it not? Yes, it would have had to. And here you got the arrows pointing north, pointing west, pointing east. And here, this one's pushing down here right over Hudson Bay. It's what is going to suspend the ice over the water? So I'm just saying, what is going to cause this? And here you see the glaciers spread north. Here they spread north and south. Here they went north, south. Here they went east, west, north, south, everything. So the main compaction would be right here. Now the scientists agree that these ice sheets were 2 miles thick, up to 2 miles thick. Well, how did they get so thick, and how did the compaction happen right here? Well, if you do a little bit of math, you'll find it takes 10 inches of snow to get 1 inch of water. Freeze the water increases about maybe 10% or so. But I'm going to say that it took 525 days of snow bearing down at 10 inches per hour, 24 hours a day, 7 days a week for 525 consecutive days. And it all happened right here. That's what we got here. And there's another one right here, the Labrador ice sheet. Well, it started right here in the middle of Labrador, had to have. And they all pushed down here, pushed down this way into lower Illinois, stopped right here at the Shawnee National Forest. Well, what I find interesting is you see this little part right here in southern Wisconsin, in central and southern Wisconsin. The ice went completely around it and didn't scar that up. It didn't scar that up, did it? No. And if we look right here, we're going to see just a little tip here. And some people are going to say, oh, well, that's just a general map. But Yosemite National Forest is down here. This comes from page 7. The last Ice Age retreat took place only 25,000 years ago, or some say 10. When the glaciers formed, great continental ice sheets also developed. They grew thick and flowed outward from their centers. See, that's where that compaction had to happen, is in the center. In North America, the main center was near Hudson Bay. Ice piled up from 8,000 to 10,000 feet thick. It did. The pressure of its weight caused the ice to flow westward and southward. But what about northward and eastward? And here again you see in Europe, the Scandinavian peninsula was the center of glaciation. Ice piled up to about 10,000 feet thick. Effects of the ice sheet. At their height, the ice sheets turned so much water to ice. What? The ice sheets turned so much water to ice? that the level of the ocean dropped almost 300 feet. And remember that. I have to use the fact that the oceans dropped 300 feet in order to accurately present this to you. The oceans dropped 300 feet. As the glaciers slowly spread out, they pushed soil and loose rocks ahead of them like giant bulldozers. Like giant bulldozers. Well, funny thing, a giant bulldozer has what on it? A huge engine that torques out many, many horsepower. There is a diesel engine there that is very powerful, and that's how a giant bulldozer pushes rocks. As the glaciers retreated, the low places they had scoured out filled up with water, forming lakes such as the Great Lakes. Well, the Great Lakes are what? 550, 560 feet above sea level, and then you add 300 to it. Well, it's going to be what? Well over 800 feet above sea level, and that's called a low place. 800 feet above sea level, ladies and gentlemen, is not a low place. It's not. It's not. Valley glaciers gouged out U-shaped gorges in older river valleys. Some of these, including Yosemite Valley, yes, Southern California, was hit with the glaciers. This comes from page 7. Spectacular as the Ice Age was, at least 3 earlier ice ages left their glacial marks on the Earth. They took place in the late Precambrian, 700 million years to 800 million, 500 million years ago, and about 230 million years ago. And here they are. And we're going to look at an illustration here. This is what happened over Scandinavia. Norway, Sweden, and Finland right here. And here's the Baltics right here. And you see the compaction had to come from the center here and from the center here, pushing outward, pushing north, south, east, and west. Here's the second one. Oh, and a little Iceland here. Well, what was over the ocean? How come we don't see all this over the ocean? And the ocean dropped 300 feet. I guess that's why we go way past the coastline here. This is the second one. This is the third one. You'll see here, north and south here, right here along the Pyrenees. The ice glaciers went north and south. Here's the third, and here's the fourth. Well, my question would be, why didn't the fourth one wipe out all evidence of the third and the second, or any of the others? How come you have subsequent ice ages that still hold true the history of the previous ice ages? That's one thing I could never figure it out, even when I was in grade school. All right, now I'll put this together just to show some of the highest points in the northern hemisphere. Denali Peak, or Mount McKinley in Alaska, is over 20,000 feet, and that mountain range is over 600 miles long. In Canada, the highest point is 19,500 feet. In Finland, 4,300 feet. Greenland, 12,000 feet. It's the highest point in the Arctic. Iceland, 6,900 feet. Michigan, 1,980 feet. Minnesota, 2,300 feet. North Dakota, 3,500 feet. Norway, 8,100. Siberia, look at this in Siberia, 13,700 feet above sea level. Now remember, the oceans were 300 feet below where they are today. So you can add 300 to each one of these and get what it was back in the Ice Age. In Spitsbergen, 5,600 feet. That's a little island north of Russia. And in Sweden, 6,800 feet. So that 6,800 feet there, that would be what, over 7,000 feet, wouldn't it? Yes, it would. Yes, it would. Remember, the ice had to come up, didn't it? Or get evaporated. What moved the ice? What created the ice? Now I'm going to show you one of my favorite books, and in this presentation I'm going to be showing you 3 of my very favorite books. And this is another one of my father's books. It came out in 1983, And I have to read this book. I've read it several times, probably 15 times cover to cover. I have to read it every so often, every few years, just to stay up on my snuff. And it's loaded with great pictures. It's only about 450 pages or so. It's just a fun read. It's absolutely fun to read this book. Now we're going to start with page 285. Pamir, the roof of the world. The roof of the world. High mountain valleys, the roof of the world. And it has over 100 peaks at 20,000 feet, right here. Has valleys and elevations of more than 12,000 feet. That means that the valley itself is 12,000 feet. This is high. This is cold. And the highest point in the entire USSR is Communism Peak, which is in this line at 24,500 feet. All were uplifted within the past 100 million years. The most drastic sculpting occurred during the Ice Age, when the entire Pamir was buried beneath an ice cap. Now get this. Although the ice cap has long since disappeared, but it's still minus 58 degrees Fahrenheit. So how did the ice cap disappear if it's still freezing? I mean, well, 58 degrees below zero? Snow covers the highest peaks all year round. Well, then where's the ice cap? Nourishing more than 1,000 glaciers that persist on the slopes. Let's look at it. Let's look at it here. There's got a picture of it. Oh, isn't that beautiful? It's majestic. Minus 58 degrees Fahrenheit. And where's the ice? Where's the thick ice cap at? Do you see it here? There might be a little glacier here, a little glacier there, here, there. Glacier-honed peaks. Glacier-honed peaks. Well, why aren't they there today? Did they just warm up and then disappear? But that's what the book says. It says that they disappeared. They disappeared. Where'd they go? Next is from page 288. Look at these majestic peaks here. We're going to see how they were formed. And look at the, here's the water level here. Remember, drop that water level 300 feet. This is in Patagonia. What made these peaks? There, snow are reminders of great glaciers that once blanketed the area there. Yep. And I like this. This is so cool. In this area, far south of the equator, southern hemisphere, the mountaintops are still covered by sizable remnants of the massive ice cap that blanketed the Andes during the Ice Age. Bet you didn't know that the Andes were blanketed by the Ice Age. Yep, they sure were. During the Ice Age, which ended scarcely 10,000 years ago, glaciers advanced and retreated repeatedly on the slopes of the Andes. Back and forth they went. Back and forth. See, there's a lot of cattle feces that the geologists have to devour to go along with these theories. And oh no, yeah, did this, did that. Yeah. They just play. We're going to show you that the Ice Age is blamed for everything. It's the cause of everything. Without the Ice Age, there is no modern day geology. Here we go again. But I got some more books to show you. This is from St. Vincent Bay. Now, in case you forgot where New Caledonia was, it is northeast of Australia, way up in the tropics there. It's north of the Tropic of Capricorn. And it's got a bay there, and with canyons in it, and well, yeah, I bet you didn't figure that one, did you? That in the southern hemisphere, the tropics were inundated by ice. A number of submarine canyons traversed the floor of the bay, evidence that it was once dry land. They were carved during the Ice Age, when so much of the world's water supply was locked up in continental ice caps that the sea level everywhere dropped substantially. Now, funny thing, whenever today the geologists have a canyon in the ocean or underneath the sea or so, they will say that that happened when it was all dry land. But when you see like the big canyon over in Canada, the big one in Mexico, and of course Grand Canyon, the geologists will say, well, that happened when all this was under water. Okay, let's go back. Let's just rephrase that a little bit. The canyons today that are deep and wide all happened, according to the geologists, when it was underwater. All the canyons deep and wide in the sea and in the ocean all happened when it was on land. Now, the two largest canyons on the planet are, first and foremost, the canyon at the mouth of the Hudson River. And the second largest canyon on the planet is the canyon at the mouth of the St. Lawrence River. Interesting, isn't it? Interesting. It's just no consistency whatsoever. But we're going to look at that. We're going to look at that. We're going to see how we throw the sciences right out the window. Next is, this is from southern Finland. You see all this flat land here and all this water? How did it get there? How did it get there? You got it. It was all smoothed out, cut down with the ice glacier. But there's also ridges here. This is from page 333. In fact, the origins of the lakes and ridges are quite different, though both are products of the Ice Age. Well, see, that ice is just all over the place. It's just doing this. It's turning up here. It's pushing stuff like a bulldozer. Then it's backing up and it's digging holes. And then the rainwater and then the runoff. And as it melts, what causes them to melt? They must just heat up real quick. And I actually saw in one of these books, I may be showing it to you, where they claimed that it was all the Ice Age ended with an internal heating of the Earth. During the Ice Age, continental ice caps advanced several miles across the ancient gneiss and granite bedrock of Scandinavia. Okay, and it went back and forth repeatedly, and we saw the word repeatedly here. The ridges are also products of the glacial retreat. So here we have the islands, the lakes, and the ridges. Terminal moraines were deposited when the Ice Age drew to a close about 10,000 years ago. As the ice melted, all the rock debris trapped in the accumulated, as it accumulated in a great mound along the front of the glacier. The glacier then stalled again, and the second line of terminal moraines. And so it stalled, and went forward, it went backwards, it melted, and it just went everywhere. Now look at these beautiful mountains here from page 346. This is the Isle of Skye. Got a pretty song about the island of Skye, which is just off the northwest coast of Scotland. Look at these beautiful mountains. There's the sea right there. Remember, that sea had to drop at least 300 feet. And what made these mountains here? What made these mountains? Well, let's just scroll down. Let's just scroll down. Within the past million years, both types of formations were scoured by Ice Age glaciers to their present contours. The higher of Skye's two mountain ranges, Cullen Hills, is 3,300 feet. Glaciation, glacier carved. One of these deep basins contains a lake with its bottom reaching 100 feet below sea level. 20 of the Cullen Hills exceed 3,000 feet. Okay, now drop the ocean. That's going to be 3,300 feet, isn't it? Yeah. Man, oh man. Boy, that piece of ice is smart, and it's busy. It's busy. And here I'm going to touch on Sleeping Bear Dunes. This is up in Michigan. And I'm going to hit on this because my buddy Zach, he likes to go up there for vacation. And here we're going to read about the dunes here. I'm just going to scroll down. Now the high points of these sand dunes are 450 feet above Lake Michigan. Okay, above Lake Michigan. Well, Lake Michigan is already what, 570 plus feet above sea level. So let's add 450 to that, and you get what, over 1,000 feet above sea level, and then add another 300 feet to that, and you get what, 1,300 feet or a little bit more? That's right. That's right. And now, how did it get there? How did it get there? How did these sand dunes get there? Look at this. In reality, Sleeping Bear and the rest of the dunes along the lake are relics of the Ice Age. Next is page 380. See this massive rock structure here? This is located in Peru, in the Andes Mountains, in a canyon of the Andes, just a few hundred miles south of the equator. Well, what happened? How did that get carved there? How did that get carved there? Well, here it is in the inscription. At the end of the great glacial episode between 10 and 20,000 years ago, meltwater from retreating glaciers poured down the mountainsides in great torrents. And that's in the Andes Mountain. Yep. And while I'm here, I'm just going to show you Lake Titicaca. Nothing special here. That's on the also, it's real close to this right here. South America's second largest lake and the highest navigable lake in all the world. And it's at 12,500 feet. Ain't that amazing? But wait a minute. That's right. Page 381. Next we have here talking about Lake Titicaca was even larger in the past. At the end of the Ice Age, torrents of meltwater from the huge ice cap that once blanketed the Andes poured into a virtual inland sea. Its shoreline was about 150 feet above the present lake level. Meltwater from glaciers. You didn't know that, did you? Lake Titicaca was formed because of the Ice Age. And it's at 12,500 feet above sea level. And just think, it was 300 feet higher than that, wasn't it? Next is page 407. Is this canyon up in Norway. It's called Voringfoss. I'm going to scroll it down before I show you the whole thing. It's just this beautiful canyon cut right into the side of the mountain there. And it's got just loaded with these waterfalls. And my question is, does that look U-shaped? But now sometimes they say the glacier cut V-shaped. So the glacier cut U-shaped, the glacier cut V-shaped. Well, what shape does water cut in a canyon? And I'm just going to scroll down here. Just going to scroll down here and let you look at it. It's beautiful. Called Voringfoss. And I'm going to come here and just kind of shrink it up a little bit so you can see the whole thing in perspective. See, little house. There's probably a bed and breakfast up here. Probably a bed and breakfast. Now, how do you think that got there? How do you think that got there? If you guessed it was the Ice Age, you would be correct. Because here we go. Here we go. Hang on. I'm going to scroll down here. The downslope finally flows into the deep glacier Card Trench, and a large glacier that lingers in the highlands. And it's just not too far away, not too far away. Voringfoss, however, is a creation of the Ice Age. See, told you. When all of Scandinavia, which is Norway, Sweden, and Finland, and Denmark, I think is still considered, was blanketed by an enormous ice cap. Now look at this. Jostedal Glacier, not far to the north, is the largest remnant of the great ice cap existing on the continent of Europe. Well, if it still exists today, and it is the largest remnant of the great ice cap, how come these other mountains don't have them? That are freezing cold all year round. They're way up. They're, what, 20,000 feet above sea level, and they're cold. They're well below freezing. They got ice and snow all year long. How come this one right here still exists, and none of the others exist? I'm just suggesting that maybe somebody ought to go back to the drawing board. My last example from this book, Reader's Digest, comes from page 419, Yosemite National Park. We're going back to California. The scenery at Yosemite was shaped primarily by the successive advances of numerous glaciers over the course of the past 2 million years. Well, excuse me, how did the ice glaciers know to go there? That's way down in, what, south central California. How did the ice know to go there each time? Successive advances and numerous glaciers? Well, how did they get there? How did they get there? Did they have a road map? Did somebody tell them? The greatest of the glacial tongues pushed far down into the ancestral valley of the Merced River, which still flows through Yosemite Valley. Well, let's hope it still flows. But what about filling it to the brim with ice? Okay, it filled it to the brim with ice. Well, where is it? As the glaciers ground their way down the V-shaped Merced Valley. Here's the V-shaped Merced Valley. They plucked chunks of rock from the highly fractured granite walls. When, let's go to the next page. This is right here's page 419. When the ice retreated, get this, the valley was left with a broad U-shaped cross-cut section and sharply defined vertical walls. Now wait a second. Let's go back one page. Glaciers ground their way down the V-shaped valley, but now they're making a U-shape. Man, I tell you what, if it wasn't for this ice age and these glaciers, what would the geologists do? What would they think? What would they think if they just bothered to read their own material? Okay, but now this is just my first favorite book. I got 2 more favorite books to show you, and this is the last entry from this book. The most recent glacier, which may have reached its greatest extent only 10,000 years ago, was smaller than its predecessors. So how do we know that? Oh, because it didn't destroy everything. There's still remnants on the outer edges of the first ones, right? Okay, all right. So like I said, there's a lot of cattle feces we're going to be eating here. A lot of cattle feces we're going to be eating. Ice glaciers. Now look at here. Look at here. I like this. The highest point in Yosemite is Mount Lyell at 13,000 feet. Mount Lyell, above sea level, and many other peaks exceed 10,000 feet. Mount Lyell, well, now who in the world is he? Yeah, so we're going to look at Charles Lyell. That's right. The highest point in Yosemite is Mount Lyell, named after Charles Lyell. And you're going to know who this guy is. You're going to know who he is here in just a few minutes. Now, we're going to look at another one of my favorite all-time books, written by one of my favorite all-time people, William R. Corliss. Unknown Earth, a handbook of geological enigmas. And this book is 800 pages of just knowledge and fun and adventure, and I have read it several times. I love this book. It is one of my mainstays. Now, if there's a geologist out there that wants to challenge me on anything, if you haven't read this book or you're unfamiliar with it, you are scholastically, academically naked. You don't know what you don't know what you're talking about, because they're not going to show you what I'm fixing to show you in college. You're never going to see in college what I'm fixing to show you. Okay, so don't even go there. If you want to oppose me and you don't have this book, you really don't have a leg to stand on. And I had a rapport with Mr. Corliss, and this book came out in 1980. What Mr. Corliss does is he compiles a lot of journals and such, scientific journals, geological journals, all kinds of things like that. He puts them in an order where you can understand them, and in different subject lines and headers. Very difficult what this man has done. And I got this letter from him when I was living down on the border working in Mexico. And you'll see here, Mr. Hubbard, thanks for the additional book orders. This time I remember to sign them. As for signatures on the first two, perhaps the enclosures will help me. Thanks also for your 2 reports. Sometime I hope you will tell me just what your business is and how these reports are published. Just curious. I think I sent him some book reviews, some book reports that I'd done. And now, this particular book, again, came out in 1980. And very interesting man. Now, if you ever called the number to a source book project, Mr. Corliss would never talk on the phone. He would never speak to his customers or to any of his colleagues over the phone. And I asked the lady that worked there, I said, well, why doesn't he, why wouldn't he? She goes, he'll write you a letter. You know, no problem there. He'll type you up a letter, but he doesn't talk on the phone. And I said, well, why not? And she makes total sense. She goes, because that's all he would ever be doing, is talking on the phone, answering questions from his biggest fans. And she's right. Okay, we're going to pick up on page 32, the drift and the ice ages. Any theory of drift formation must account for these singular accumulations, as well as an immense family of scratches, lake basins, and various gougings. The continental ice sheets of the glacial epoch are commonly credited with this colossal sculpturing. Although the ice ages have assumed the status of scientific dogma, some facts of the drift are not in accordance with the theory, and the problems are drift deposits and apparent glacial striations well south of the charted ice sheets, erratic blocks hundreds of feet above their quarrying points that call into question the motive force pushing the ice sheets and their mechanical strength. Had a big engine, it's a bulldozer. Okay, these ice sheets were pushing rocks like our modern day bulldozers can't even attempt. Striations indicating northward motion, which I've already showed you. Boulder trains and associated erosion that seem to demand cataclysmic flooding. Geological convulsions, indeed, may have sculptured northern terrains, but the anomalies presented below have not significantly reduced the number of Ice Age believers. And I don't think that this video here will be, as far as the geologist goes, he's not going to throw in the towel and say, okay, I don't believe in ice ages or ice glaciers theory. This Harry Hubbard, he just doesn't know what he's talking about. They make their living teaching what I am opposing here, okay? So it's not going to change their attitude, and they're not going to think past their nose. But I'm going to be showing you a lot of information here that don't make a whole lot of sense if you think. The drift phenomena around the world have been interpreted by many geologists in terms of the glacial theory. A great many problems of a fundamental nature are involved with this interpretation. The cause of the ice ages has never been determined. That's interesting, isn't it? All of these facts suggest that the reality of the ice ages has not been proved. All right, but are they going to stop teaching it? No. There are many things that have not been proved, but does that stop anyone from teaching it? No, they teach it as fact, and they always will, they always have, and that's how they make their money. If there was a geologist trying to get on at some college, or even a Christian university, complaining that there ain't no ice ages, like me, for instance, that there was no ice age, there's no proof of glaciation, you think they'd get hired? No, I doubt it. The mantle of unconsolidated material similar to that of Europe and North America also occurs in parts of India, in South Africa, the tropical zones of South America, and in many mountainous areas of the world, usually referred to as drift. The word drift means anything you want it to. The material is also known as boulder clay, diluvium, outwash, deposits, glacial, moraine, and till, and loess. You could also say loess, and that's just what they do. They make it up as they go, and they give it all these fancy names. Make it up as you go. Let's go next page. This is page number 34. The rimmed plateau and prairie mounds are explained in the glacial theory as landforms created during the melting of the great ice sheets. The glaciers, it is believed, sometimes melted, get this, in such a way that isolated blocks of ice were formed that wasted away and deposited their debris in various kinds of rimmed structures and plateau. Drumlins and flutings, which drumlin is a small round hill. We'll look at it here. Explained as the effects of the movement of the drumlins are hills shaped like the inverted bowl of a spoon. Glacial flutings are similar, elongated parallel ridges and troughs. And these may stretch for several miles in the prairies of Canada and parts of North Dakota and Montana. Drumlins and flutings are often composed of drift, but many are bedrock and partly bedrock. So they don't know. Look at this. Geologists believe that the last of the ice disappeared only a few thousand years ago. Striations are frequently present on the surface of the bedrock, underlying and attributed to the ice sheets in the glacial theory. As the ice sheet moved, it is supposed there were large numbers of stones carried along in its base that gouged the bedrock as the ice sheet went along. We're talking a Caterpillar bulldozer 100 times the size of what we have today. My goodness, and so much more powerful. Large boulders found in some regions with a composition quite different from that of the bedrock in the vicinity. And here we go. Large boulders of quite different composition are known as erratics. And I know you geologists that you've been waiting. What about erratics? You've been waiting for me to mention erratics. What about erratics? What about it? How do you explain that? How do you explain that? You've been waiting for it. And are considered to have been transported from regions afar by the moving ice sheets. These may sometimes be as large as houses. Some of them are several acres large. We're talking huge. Some of them are the size of several houses put together, and are usually rounded, though some are of irregular shape. So it doesn't matter. It can be on top of the ground. It can be round. It can be square. It can be rectangular. It can look like a crag. It can look like a small miniature mountain. Do they care? No. No. It is an erratic boulder. The rise of the glacial theory. A leading exponent of the diluvial theory of the drift was William Buckland of Oxford. He was among the first, however, to abandon this idea in favor of the glacial theory of Louis Agassiz, who we're going to get into a little bit more here. And here's our buddy Charles Lyell, however, still favored the iceberg theory for most of the drift. So they have these. We're going to see some contradictions here. The glacial theory accepted, but with some opposition. Agassiz came to America in 1846 and energetically proclaimed the glacial theory while teaching at, get this, Harvard University. Gradually, the theory of a great glacial age gained acceptance. And then is when they started putting it all together, putting not one, not two, not three, not four, and then just going back and making as many glacial ice ages as they could, as they wanted to. That explains it. If this ice age doesn't explain it, let's invent and create another one, and that will do it. Although strong opposition was voiced by geologists such as Dawson and Howarth, which we're going to look at some more Howarth stuff. Howarth wrote numerous articles against it, saying it's a bunch of crap. His idea of a violent, catastrophic origin of the drift was ridiculed. This is still on page 35. Many of the assumptions involved in the glacial theory, Howarth argued, are contrary to physical laws and known facts about the properties of ice. And that's what I've been saying. Okay, physiologically, the ice is not that smart. Okay, ice is very dumb. Ice can only follow gravity, and the physical laws known as and known facts. Physical law. These geologists, they throw physics right out the window for their theories, and other disciplines in the scientific community, they'll throw some other discipline of the scientific community just right out the window. Just throw it under the bus, get rid of it. We don't want to have nothing to. Anthropology does it, archaeology, paleontology. does it. They all do it, and the geologists are known for it. You take away their ice age theory, they have nothing. They don't have anything except mineral composition and identification of minerals. That's it. That's it. A catastrophic alternative, which I'm a catastrophist, and I believe in a catastrophic alternative. How the present state of opinion arose. Whatever the reasons, most geologists slowly accepted the theory of ice ages, and the idea of a worldwide flood was relegated to the limbo. So, back then in the 1800s, a lot of people, a lot of geologists actually thought that it was Noah's flood, I guess, or a worldwide flood that caused the erratic boulders or this or that. Well, they just changed it from water to ice. They wanted something besides Noah's flood, which I don't believe covered the whole earth. I think it just covered a certain portion of the Middle East. There's no one that has been told, none of the creationists have told me, or the Christian scholars, they don't know if it was salt water or fresh water of Noah's flood. They don't have that. And it certainly couldn't have been a flood to cover the whole world, because what did the dove bring back in his mouth? An olive tree, an olive branch. And it takes like 9 years for an olive tree to grow its first branch. So that didn't happen, but they don't do that. They don't do that. Throw logic, throw biology out the window, which we're going to see here in a minute, how biology's thrown out the window. They simply wanted something else besides Noah's flood. They wanted a scientific method that was different from Noah's flood. And it's the same way with the Darwinists of the 1800s. They wanted something else besides creation as it was in the Bible. This is me, Reed, writing in 1896. The phenomena of the glacial period in Britain contain some of the most interesting problems there's yet been the lot of geologists to attempt to solve. It therefore behooves us to approach the subject in a spirit of humility. That such varied explanations have been proffered from time to time, that most contradictory conclusions should be drawn from well ascertained and generally acknowledged facts, is curious and somewhat depressing. There is, however, this reflection to comfort us, however strange, however contradictory, however devoid of common sense the various explanations and theories of the glacial period appear to the various observers and reasoners upon them, the total effect is, like that of the hypothetical ice sheet, a push forward. Which he's saying there, that no matter if it's wrong, at least we're thinking about something else. And that was what? 1896. Page 37. With this rather uncertain foundation, the glacial theory became the backbone of geological research on the drift phenomena. Difficulties in the glacial theory. The layer of drift is the main body of evidence for the glacial theory. See that? The remnants are the evidence. When one considers how this material is distributed, considerable difficulties arise in the notion that it has been caused by glaciers. It is not present in many areas where one would expect to find it, and it is present where one would least expect it. Thus, in the northernmost parts of Greenland and in the islands of northern Canada, no drift is present. But it is found in tropical areas such as the Amazon jungles. That's right. Regarding the tropics, right at the equator, no less than an authority than Louis Agassiz wrote, there were drift accumulations and scratched rocks and erratic boulders and fluted valleys and the smooth surface of tillite. Yep. Down on the equator. The presence of drift has been reported from such places as British Guinea, Equatorial Africa, Madagascar, and India. Wherever the characteristic features of the drift are found, it seems necessary to postulate former glaciers to explain it. See what I'm saying? There I am. There I am. Let's just blame it all on the glacier. The theory of continental drift is partly an attempt to explain how the ice sheets could have existed in these areas at various periods in the past. See now we're coming back to my continental drift theory, which I'm going to be touching on a little bit, but not much, because I've covered it and I'm going to be covering it a little bit more. But look here, you got to have the continental, you got to have your ice age theory to make a continental drift theory work. Okay, the glaciers of mountain regions and the ice sheets of the Antarctic and Greenland do not seem to be forming any deposits similar to the layer of drift that has been attributed to ice sheets of the past. Moving forward. The postulated ice sheets of North America and Europe are also somewhat lopsided and do not conform to the polar regions as one would perhaps expect they should. What does that mean? Okay, and accounting for this has been a real brain twister for the glacial theorists. What does that mean? It means that they're lopsided. They're not, you got like North Pole and South Pole like we have today. This is like, it's like blemishes on the Earth, just erratic, just spasmodic, wherever you want to put them. Wherever you want to put a glacier in an ice age, well, let's just put it right there. Just put it right there. And it has no conformity as far as how we know weather-wise where warm weather and cold weather is located, which would be colder at the poles. Hello, duh. But geologists don't realize that. A geologist does not realize that the poles are colder than the equator. They just throw that right out the window. Don't believe it? Read their material. Don't read their material. They certainly don't. But like I say, there's a lot of cattle feces that the geologists are having to eat. The cause of an ice age still undetermined. Next page. Page 38. Coleman, writing in 1929, and this paper was written in 1976. Scores of methods accounting for ice ages have been proposed, and probably no other geological problem has been so seriously discussed, not only by glaciologists, but by meteorologists and biologists, and yet no theory is generally accepted. The opinions of those who have written on the subject are hopelessly in contradiction with one another, and good authorities are arrayed on both sides. Okay? Opinions of those are hopelessly in contradiction. So they just throw each other under the bus. That's all they do. That's all they do. The geologists throw weather patterns right under the bus. Problems about the motion of the ice, and you can read this, it's pretty interesting. Inherent in this assumption is the notion that a great ice sheet would actually move. The ice sheet should be limited to downhill gradients in the topography underlying the ice. Wouldn't you think that would be a good statement? No. Not to a geologist. A geologist is going to tell you that all of these glaciers moved uphill. They moved uphill, they moved north, they moved south, they moved everywhere because of compaction. But they're not going to give you any... let's just keep going here. Page 39. And here it is. As of any other viscous body to travel over enormous stretches of level country and up and down long hills, as it must have done if the glacial theory is to become the final and effective explanation for a large part of the drift phenomena. The idea of sliding or moving of the base of the ice sheet over the countryside due to an unknown factor in the ice sheets has been conceived. Okay, well, I got an idea. Had a big engine on it with a great big blade. It just pushed right through. Had a big diesel engine on it. That ice, it was just fantastic. It's just fantastic. Here, bottom of page 39. It is not known how the movement of the ice was accomplished. I just explained it to you. It had a big engine on it. But geologists accept as a fact that somehow fossil sliding of the ice sheets over vast distances occurred. They don't know how to move. They just make it up. A geologist makes it up as they go, but they have to dance with those that brung them. This is in all of the geology books. There's nothing different except what you're fixing to hear now. This is the Harry Hubbard University course on geology, and it just throws Ice Age theory under the bus. We're just getting going. Stick with me here. I got several more pages from this book to show you. Picking up on page 40. Sir Holworth claimed that the movement of ice sheets is viscous flow, and there could be no unknown or mysterious properties in the ice of the glacial theory that could cause movement in ways not evident in the ice known today. In other words, you can't make it up. You can't make it up as you go. That ain't going to work. That goes against the scientific method, does it not? If the ice has to move uphill and therefore to overcome gravity, the difficulty of moving it in mass will be increased, and the length of the column of ice capable of being moved will be proportionately lessened. Let's scroll on down here a little more. Not only is it necessary to assume that the base of the ice in the great ice sheets of the glacial period was capable of moving for great distances over irregular country and frequently uphill or up mountainsides, but the boulders it transported are thought to have been lifted upwards by the ice, so that now they are often found at altitudes much higher than those of the source beds from which the erratics are supposed to have been derived. And Flint provides these examples. In Maine, erratics at Mount Catawden have been transported at least 18 kilometers, lifted 1,000 meters. Erratics in the Adirondacks have been transported at least 100 kilometers and uplifted 900 meters. Allegheny Plateau, central New York, the rocks were moved 160 kilometers and lifted 500 meters vertically, straight up. I don't even think Caterpillar makes an engine that strong. On Killington Peak in Green Mountains, Vermont, rocks have been transported possibly 80 kilometers and lifted 900 meters, apparently by the ice. In the Rockies of Alberta, rocks have been moved a distance of 1,300 kilometers and uplifted 1,300 meters. Other examples are cited in Alberta, Manitoba, Northwest Territories, and from Erie, Germany, and Wales. And here's Holworth again. The question is one of mechanics to be dealt with by mechanical arguments, and it seems to me to be the height of rashness for geologists who are quite guiltless of any training or knowledge of or such as physicists to appeal to transcendental causes whose potency they have not tested. They don't matter. A geologist, they don't care. They just make it up as they go. Here it is. Ice and ice alone did it all. They have to attribute to ice qualities which it not only does not possess, but which are contrary to the very elementary laws of matter. How could the ice move uphill? Far from actually proving the reality of ice ages, erratic boulders, in fact, pose a perplexing problem for this theory to explain. The ice not only has to be capable of basal movement over very great distances, it also has to move uphill for distances of hundreds of miles, which is contrary to any experience we have of glaciers and ice sheets today. Scroll down here a little more. As Sir Henry Holworth insisted, ice as we know it moved downhill under the influence of gravity. Hey, I tell you what, now isn't that common sense? But let's just throw it out the window. Page 42. It is ice sheets they rely on, portentous ice sheets, such as no longer exist anywhere. A Saturnian postulate, in fact, is their platform, and not a mundane one. They stand fast on their ice glaciers because they want to keep their job, I guess. Yet it ought to be a condition, even of such a transcendental postulate as this, that the ice in an ice sheet should act in accordance with, and not contrary to, the nature and the physical qualities of ice. It's just ice. If it does not, the appeal ceases to be a scientific appeal. And it is, in fact, very largely an unscientific appeal, which means it's empirical. It's unscientific, it's empirical. An unscientific appeal, which is continually being made by this noisy, clamorous school of writers who never verify their premises and make assumptions as readily as they abandon them. And now, who verify their premises and make assumptions as readily as they change their mind all the time. They have to change. Oh, well, and that's what a geologist is going to do. Well, that right here is the glacier went this way. Well, the glacier went that way. Then it went uphill. Then it went downhill. An ice sheet is only a great mass of ice, after all. Duh. A mass of ice which, instead of lying on a mountain slope or being embayed in a valley or on a plain surface, is supposed to have smothered and covered a stretch of uneven country and swathed it in a continuous mantle. Such a mass of ice cannot acquire properties not possessed by other ice. If it moves, it must move according to the mechanics of ice, and as we have seen, ice moves in no other fashion than by the influence of gravity. And here's up paradoxically, this flow must have been frequently uphill. In northern New York, the drumlins, which are these rounded hills, are oriented north-south, and the direction of flow was uphill from Lake Ontario. And this other drumlins, it's all flow uphill. It's all uphill. Then bear in mind, the oceans were 300 feet below where they are now. Let's go to the next page, page 43. And here we're talking more about the drumlins. More mechanical difficulties. Ice not strong enough. Sir Henry Haworth pointed out that there is a limit to the size and ice mass that could be pushed bodily. If the extent of the ice sheets were greater than 7 miles, he claimed, the ice would just crush and fall apart, which I'd say couldn't even be that much. I'm just saying it could possibly fracture and just crumble. And I like this entry here. How could the ice have melted and still be at work? How could the ice carve the surface of the drift after it had melted? Hey, I'm just asking. I got the same questions. These are paradoxical facts inherent in the glacial explanation of the drumlins, and streamlined landforms do not in any way support the idea that ice ages have occurred. They are actually objections to the idea of great ice sheets that ought to have planed off the country they overrode. And here's Warren, who wrote, could ice have carved the rocks? According to the glacial theory, the layer of drift on the continents was formed during the melting of the ice sheets. So how did the rocks get formed? How did it happen? Was it because it was retreating, or was it going? Well, the geologists will just make it up as they go. They have no clue. They have no answer. And when I start out, they just get mad and run off. I don't get along good. I met a geologist years ago, and he was doing so. I'd paid him to do some survey work for me, and I told him straight up. I said, "Man," we were riding back in my truck. And I said, man, I got to be honest with you and up front, I don't like geologists. And he looked at me, he tipped his hat, and he said, I don't either. Sir Henry Haworth objected to the assumption that the ice sheets could have broken up their beds as they moved. He wrote, ice is much softer and more easily crushed than the great majority of rocks. Duh. And would itself be crushed and reduced to slush by its own pressure long before the rock upon which it stands could itself be broken. We must always remember the kinds of materials upon which the supposed crushing was effected. Hello? Somebody out there's thinking, the lumps of soft rock showing crushed outlines, but clean, broken, and shattered masses, with their surfaces still raw and unhealed. consisting of the hardest crystalline rocks such as granites, syenites, porphyries, etc., as well as limestone, sandstones, and chalk. And we are asked to believe that the same ice sheets which thus shattered such intractable materials in situ, after passing on a few yards, traveled over beds of laminated and stratified sand and loam with such a gentle touch as not to disturb the laminations. Wow, so it crushes rock 1 minute, and then 10 feet later it just leaves, it's so gentle to the ground. The word impossible is not a favorite one of mine, but I am bound to say that if it is to be applied to any physical operation, I know of none where it seems so applicable as to the process appealed to by the ultra-glacialists for the manufacture of drift by an ice sheet smashing its own bed. And that concludes my entries from this book. I think William Corliss was brilliant in putting all this together, and he has a lot of his own comments too. Now let's go to another one of my favorite books. Now we're going to look at another one of my all-time favorite books by Immanuel Velikovsky. He's got several books I really like. It's called Earth In Upheaval. And now we're going to see where such a stupid idea as ice glaciers and ice ages comes from. We're going to now start to see where it comes from. Let's see the birth of it. This comes from page 34. Chapter 4, Ice. The birth of the Ice Age theory. In 1836, Louis Agassiz, who we already met, from Switzerland, went with Professor Carpentier, another naturalist, to an alpine glacier to demonstrate to him the fallacy of the new idea that an ice sheet once covered a large part of Europe. 4 years before, a teacher in a small town forestry school, Bernardelli had written, once the polar ice reached as far as the southern limit of the district, which is still marked by the erratics. And as far as Velikovsky knew, who was from Russia, brilliant guy, this was the first mention of any of it. At the edge of the glacier, Agassiz, who came as a skeptic, was himself converted. He became the chief apostle of the new theory, or the new religion. Basically, he's writing, and you have to see Velikovsky's humor is just very, very deep, very, very deep. He built a hut on the glacier of Aar and lived in it, so that he could observe the movements of the ice. And everybody was really impressed with that, really impressed. So now we're seeing where it came from. Agassiz made his conclusions with respect to other parts of the world on the basis of observations limited to Switzerland and its surroundings. That's right. He thought that if he could convert two of the leading geologists, Buckland, the author of this book, and Murchison, to the Ice Age theory, and thus win their support, the task of gaining recognition for it would become much easier. Haven't we seen that in more recent times too? Among the older naturalists, one stood by me, Dr. Buckland, Dean of Westminster. We first went to the Highlands of Scotland, and it is one of the delightful recollections of my life that as we approached the castle of the Duke of Argyll, standing in a valley not unlike some in the Swiss valleys, I said to Buckland, "Here we shall find our first traces of the glaciers." And as the stage entered the valley, we actually drove over an ancient terminal moraine which spanned the opening of the valley. It was a setting for revelation, Agassiz wanted a follower. How poetic, how prophetic, how convenient. A few weeks later, November of 1840, Agassiz read a paper before the Geological Society of London, surmising the excursion in the light of the Ice Age theory. And Buckland, who was then president of the society, followed with a paper of his own on the same subject. Even before the meeting, he had written to Agassiz of the success of his missionary work. Look at that, his religious work. Lyell has adopted your theory too. Now, who's that? That's Charles Lyell. Lyell has adopted your theory in toto. On my showing him a beautiful cluster of moraines within 2 miles of his father's house, he instantly accepted it as solving a host of difficulties that have all his life embarrassed him. Lyell, too, agreed to read a paper less than 3 weeks after this episode. Man, oh man, 2 miles away from his house, his childhood home. At the November meeting of the society, Murchison attempted an opposition, but, in the words of Agassiz, did not produce much effect. He added, Dr. Buckland was truly eloquent. That same year, 1840, Agassiz published his theory in a work titled Etudes des Glaciers. And here, if you want to read that. Now, we're going to go to page 37. Thus, Agassiz maintained that the Western Alps had risen very recently at the end of the last ice age and were younger than the carcasses of mammoths in Siberia, the flesh of which is still edible. These animals, he thought, had been killed at the beginning of the ice age. It is often said that Agassiz added from 500,000 to 1,000,000 years to the recent history of the world by inserting the Great Ice Age between the Tertiary, or the Age of Mammals, and the recent, comprising Late Stone Age. Remember, this is mid-1800s. That the 1,000,000-year span for the Ice Age is Lyell's estimate, and he interpreted Agassiz's theory in the spirit of uniformity. When it comes to the theory of uniformity, Velikovsky is just all over the place. He really destroys that. The theory of a continental ice cover was acceptable to Lyell. He agreed to it, satisfied to go no farther than, for his proof, than 2 miles from his home. That proves it. He realized that floating icebergs could not explain the phenomena of drift and erratic boulders in all places. The only alternative had been the waves of translation, or tidal waves traveling on land. But this was outright catastrophic. Now, with the continental ice theory, he felt he had the correct solution if the catastrophic aspect of the theory was as originally suggested by Agassiz. A follower of Cuvier was eliminated. It was not yet asked what produced such a cover. Let's not ask the question of where the ice came from. Let's not ask what produced the ice. We're not going to go there. Next, page 38. On the Russian plains, soon after the historic meeting, at which the Ice Age theory was accepted by the majority of the members of the Geological Society, Murchison went to Russia, where he had been invited by Tsar Nicholas I to make geological survey of the empire. So that's going to be, what, 1850 or so, or late 1840s. Okay, now we're back to the late 1840s with Murchison, and this is just after he completed his survey for Tsar Nicholas I. Murchison rejected the application of the terrestrial glacier theory to Sweden, Finland, northeastern Russia, and the whole of northern Germany. In short, to all the Low Countries of Europe. Ice flows descending from these glaciers carried angular broken stones over land covered by sea and dropped them on top of the drift created by the eruption of the sea. Murchison called attention to the fact that Siberia is entirely free from erratic blocks or erratic stones, though environed on three sides by high mountains. There's three mountains that enclose Siberia, and there weren't even any glaciers that were pushing the boulders down the mountain. Hey, you go figure. This man is on top of it, isn't he? Ice Age in the tropics. Remember, I touched on that a little bit more. This is a little bit more detail on it. In 1865, and this is what 20 years after he started his pastoral tour. In 1865, Agassiz went to equatorial Brazil, one of the hottest places in the world, where he found all the signs he ascribed to the action of ice. Now, get this, now even those who had previously agreed with him became distressed. An ice cover in the tropics on the very equator? Well, why not? Why not? It was like a drug. It's like it's overcoming. It's everywhere. You just got to have more. Got to have more. Got to have more. What could have caused a tropical region to be covered by ice several thousand feet thick? What, 10, 12,000 feet thick? To over 2 miles. 2 miles thick. Yes, sir. Yes, sir, indeedy. Abundant vestiges of an ice age were likewise found in British Guiana, another of the hottest places on Earth. But I'm getting there. I'm getting there. I got some other cool stuff. Soon, the same word came from equatorial Africa, and what appeared even more strange, the marks were indicated not only that equatorial Africa and Madagascar had been under a sheet of ice, but that the ice had moved, spreading from the equator. Get this, toward the higher latitudes of the southern hemisphere, or in the wrong direction. Well, my goodness. So now we have the ice age starting on the equator and moving towards Antarctica. Then vestiges of an ice age were discovered in India. Well, yeah, of course, it's a drug. And there too, the ice had moved from the equator, and not merely towards the higher latitudes, but uphill from the lowland up the foothills of the Himalayas. Wow. It doesn't get any better than this. It doesn't get any better than this. The ice cap covered practically all of the southern Africa up to at least latitude 22 south, and also spread to Madagascar. Even if the phenomena took place very long ago, an ice cover thousands of feet thick in the hottest places of the world is a challenging enigma. I say so. Isn't it though? Isn't it though? I love this one. I like it. The Ice Age survived in Greenland. This Arctic island reveals how vast continental areas looked in the past. However, it does not explain how ice could have covered British Guiana or Madagascar in the tropics or the equator. And, what is no less surprising, the northern part of Greenland, according to concerted opinion of glaciologists, was never glaciated. What? That's right. The islands of the Arctic archipelago, writes another scientist, were never glaciated. Neither was the interior of Alaska. That's what I'm saying, ladies and gentlemen. You have to be consistent. And if you're going to say that all, but now that one map I showed you, it did have the center of Alaska glaciated to some extent. But why the polar lands were not glaciated during the Ice Age was never explained. Of course not. At present, the surface of Lake Michigan is at 582 feet above sea level, or 570, give or take a few, plus 300, which means during the Ice Age it would have been over 800 feet here above sea level. Bones of whale have been found 440 feet above sea level north of Lake Ontario. A skeleton of another whale was discovered in Vermont, more than 500 feet above sea level, and still another in the Montreal, Quebec area, about 600 feet above sea level. Although Humphrey whales and beluga whales occasionally enter the mouth of the St. Lawrence, they do not climb hills. And there we see Velikovsky's humor. Therefore, the accepted theory is that the land in the region of Montreal and Vermont was depressed more than 600 feet by the weight of ice and kept in its position for a while after the ice melted. And then there was the other one that had that the ice was so heavy that it actually warped the Earth's crust. It warped the Earth. Oh my goodness. Yeah, how do you know that? Well, why hasn't it got a big hole? And opposite the mouths of the St. Lawrence and the Hudson rivers are deep canyons stretching for hundreds of miles into the oceans. These indicate that the land became sea, being depressed in post-glacial era. All right, now let's go to page 48. Right here at the bottom. In Georgia, my home state, in Georgia, marine deposits occur at altitudes of 160 feet, and in northern Florida at altitudes of at least 240 feet. Walrus is found in Georgian deposits. Pleistocene Ice Age marine features are also along the Gulf Coast east of the Mississippi River, in some places at altitudes that may exceed 200 feet. Now, I want to point something out. I did a lot of hiking on Lookout Mountain, which stretches from Tennessee through northwest Georgia all the way down into Alabama. And on the southern end of Lookout Mountain in Alabama, there's a place there off the highway where you can go and you can see marine deposits, all kinds, just millions and billions of these little tiny shell creatures embedded in the side of a cliff. And it stretches for about 250, 300 feet, and it's probably about 20 feet deep and about 15 feet high, 15 feet thick. And it's stretched, and it's right there. It's all kind of pinkish looking. And you can go up there with your hand or your thumb and you can just scrape it away. But how did that get there? It's probably at about, I'd say over 1,200 feet ASL. And it's all washed up into the side of this crevice. Right, you can actually walk underneath it. It's got big rocks underneath there. And there's also 4 huge stones of pink granite sitting right on top of Lookout Mountain. And the geologists say that those are erratics. So they would have had to come from gosh knows where. Pink granite. It's right there off the highway. You can drive right through them. And lift them up, 1,600 feet? Yep. Let's blame everything on the glacier. And now, coming to a close here. These areas are not were not covered by the ice, which, advancing from the north, reached only as far as Pennsylvania. And they call it just the corner of Pennsylvania, and this was in 1955. Now, since then, they have changed the moraine and the outlook and the destination and where the glaciers started. If you go back and you look at old geology books, they have changed where the glaciers stopped many times through the years. Daly concluded, the Pleistocene history of North America holds 10 major mysteries for every one that has already been solved. I got to agree with that. Page 108. The other fundamental teaching originating in the 19th century, the theory of ice ages, has been loaded more and more heavily with the responsibility for the geological facts revealed. However, the cause of the ice ages remained a much discussed and never agreed upon subject. Next page, 109. And this is according to Professor Coleman. When one considers the distribution of ice sheets in the Pleistocene covering 4 million square miles of North America and half as much of Europe, and the ice in Greenland, Iceland, Spitsbergen, the southern island of New Zealand, and Patagonia in South America, it becomes evident that all parts of the world could not have been elevated, next page, at once. The theory breaks down of its own weight. Therefore, elevation above snowline would cause local glaciation, but there is no evidence that large-scale ice sheets can be formed in this way. Scroll down. Scores of methods accounting for ice ages have been proposed, and probably no other geological problem has been so earnestly discussed, not only by geologists, but by meteorologists and biologists, and yet no theory is generally accepted. A true theory of the origin of ice ages, whether resorting to astronomical, geological, or atmospheric causes, must also explain why ice ages did not occur in northeastern Siberia, the coldest place on Earth, but did occur in temperate latitudes and in much more remote past India, Madagascar, the equator, and equatorial Brazil. None of the theories mentioned explains these strange facts. Jumping over to page 114, the explanation that appeared best to the geologists was rejected by the physicists and astronomers, who for their part could not propose any other satisfactory solution. Probably mechanical engineers as well. Anybody that knew anything about friction. Next is page 117. And I'm touching on this because I've mentioned it in one of my other videos, how I don't buy any of the continental drift theory. That's another go-to for geologists that I don't believe for one second. And there are other people that have problems with it too. Go pick up here, page 117. In August of 1950, the British Association for the Advancement of Science devoted the sessions of its annual convention to debate on the question, is the theory of the continental drift right or wrong? There were many defenders, next page, 118, of the theory, and as many opponents. The theory was then put to a vote. They vote on this stuff. Democratic decision. The result was an even decision between yea and nay. The chairman was entitled to cast the dissenting vote, but abstained. Only thorough and fortuitous circumstance that the presiding officer was a conscientious or undecided person was the sanctification of continental drift averted. That's it. That's it. They vote on it. Yes, whoever buys lunch gets their way. Now let's go to page 130. Evaporating oceans, one of my favorite subjects. If we take into account the area occupied by ice in the glacial epoch, much larger than the area of the present polar ice, we must conclude that the shifting of the poles alone cannot explain the origin of the glacial cover. The expansion of the glacial cover in its various stages is supposed to be known. The usual estimate of its thickness is between 6,000 and 12,000 feet. From these figures, the mass of the ice is calculated and the quantity of water necessary to produce it. The water must have come from the oceans. Page 131. It is estimated that the surface of the oceans must have been at least 300 feet lower, which we've been talking about, when the ice cover was developed. Some estimates, get this, double, triple, quadruple, and even increase sevenfold this figure. But for all the oceans to have evaporated to such an extent, turning many areas of the continental shelf, the sea at the coast to a depth of 100 fathoms or 600 feet, into a desert of sand and shells, an enormous amount of heat was necessary. Got that? Where'd the heat come from? Many of them, the geologists, seem to have overlooked the fact that the enormous extension of glaciers in bygone ages demonstrates just as rigidly the operation of heat as well as the action of cold. Cold alone will not produce glaciers, or ice sheets for that matter. Now this is a good paragraph here. I'm not going to read it, but it is very interesting. I'm going to scroll on down here. If this is so, then none of the theories offer an explanation, next page, 332, of the Ice Age really would account for it. Even if the sun disappeared and the Earth lost its heat to cosmic space, there would be no Ice Age. The oceans and all water would freeze, but there would be no ice formation on land. Got that? Scrolling on down here. A tremendous heating process must have preceded the formation of the ice cover. And here you go. So we're at least 4 glacial periods. We've seen that. In a recent geological epoch, must have been repeatedly so hot that the portion of the heat the oceans received would have sufficed to turn an immense mountain of iron 5 times the mass of the continental ice cover to a white glow and melt it. According to Tyndall, if this did not happen, there could not have been any ice ages. If we subscribed to the Ice Age theory, we must assume that the terrestrial globe with its oceans was heated as in a furnace in the age of man, since the Ice Age, together with the recent, is the age of man. I got one more thing to show you. Well, I'm going back to the Reader's Digest book, and I'm going to show you page 371. I'm not making this up. This is printed. Scientists have also established that parts of the Sahara were once covered by an ice cap. Thus, astonishingly many traces of glacial debris are incorporated into the rocks throughout this hot, dry land. If you didn't think that I couldn't put the ice glaciers in the Sahara Desert, I've put them at the equator, I've put them at the Himalayas, I've put them all over the Andes Mountains, all over Alaska, the Rockies. I put them everywhere. I put the Ice Age now in the Sahara Desert. Now, I debated whether or not to include this in this video, Animals of the Ice Age, and this comes from volume 9, page 7 of the same World Book Encyclopedia. But I figured, what the heck, you know, and because it concerns the Bering Strait, which to me, I may do something on that one of these days. The modern horse, camel, and elephant first appeared in the Ice Age. Well, there's no specific of which one. Could have been the 1st, 2nd, 3rd, 4th, or even the 10th. Who knows? The horse and camel originated in North America, which that is pretty much understood. Then they crossed the Bering Strait into Asia. Well, it wasn't a land bridge, ladies and gentlemen. It had to have been an ice bridge, correct? Yeah, had to have been an ice bridge. Well, can these animals walk on ice? No, they can't. There's only like a few mammals that can walk on ice. The polar bear, the wolverine, maybe the caribou. Elephants, bison, buffalo, deer, and bears that evolved in Europe and Asia came to North America. Well, they had to have been traveling along the coast where there was no water and there was no ice sheet, and it probably was pretty narrow. What, maybe 300 yards maximum? So they must have passed each other, unless you want to make up that they were billions of years apart, and you just have to eat more cattle feces to prove the point here. Okay, now get this: horses, llamas, giant ground sloths, and armadillos migrated to South America. What? Giant ground sloths? Ladies and gentlemen, these animals here were the size of a semi-tractor. They were huge. Their bones are the size of trees. And they moved very slow. I doubt very seriously if any giant ground sloth ever died with 2 or 3 miles from where he was born. They're very, very slow. And what did they eat? And can you imagine these giant ground sloths, llamas, and horses traveling over some of the roughest terrain on the planet? We're not talking flatland here. We're not talking flatland. Well, what did the ground sloths that migrated, what did he tell his offspring? Did he tell them, keep going south? Keep going south. So evidently the ground sloths, the horses, and the llamas, they knew the difference between north, south, east, and west. They had to have, right? If they were going to South America, oh, they were just staying in front of the ice sheet that was coming down through Central America, correct? Yeah, and North America? Yeah, I guess so. I guess so. But how did the giant ground sloth migrate anywhere? That's the slowest moving mammal on the planet. And as far as I can detect, there's only a couple of animals that migrate, and I mean long distances, birds and humans. I mean it narrows the field. I'll guarantee you that there's never any giant ground sloth that migrated anywhere. I just thought this was cute, so I decided to include it here. Thank you for staying with me. Hope you've enjoyed it so far. And I got a couple of questions still left. I want to ask the geologist, how high were those snow clouds that produced 20 miles thick of snow to compact down into 2 miles thick of ice? How high were they? Well, if it's going to be 20 miles of snow to pack down, oh, well, it didn't all happen at once, Harry. Well, then, it happened over millions of years. Well, then, just pick a number. What was the elevation of your snow clouds as they packed down 2 miles thick of ice sheet? I want to see that. Well, the geologist, he ain't going to have a clue because he has been eating cattle feces all his life and all his institutionalized career. That's all they've been doing. He's going to have to reach into a hat to answer this question and pick a number. And I'll guarantee you there's no two geologists that are going to answer that question the same way. Of course, I know none of the books ask these questions that I ask. How high were the snow clouds as they rained the snow down? And they say, well, it happened over millions of years. Tell me how high they were. Okay? And tell me how many millions of years? Oh, okay. Well, that's going to be an issue. It's going to be a problem. And some more numbers. They agree that it was 17 million cubic miles of ice. That's a lot of ice, isn't it? And this 17 million cubic miles of ice, they weighed a total of 68,000 trillion tons. I don't even know what that number is. 68,000 trillion tons. That's a lot of ice. That's a lot of ice. And I also want to throw this in, because now I've been accused a couple of times of people saying to me, you can't prove anything, Harry. You can't prove anything. And it's a new philosophy on the internet and on YouTube. You got these wannabe philosophers out there telling people you can't prove anything. That this is all an illusion. Can't prove anything. If anyone ever accosts you and tells you that you can't prove anything, just ask them one simple question. Can you prove that I can't prove anything? It don't hurt to ask, does it? Watch them lock up. Their brains will just lock up. Thank you, and I hope you enjoy some of these pictures at the end. Until next time, peace out.